Many process systems have to be supplied with a variety of fluids in order to operate properly, and a maze of piping systems carries these fluids throughout the plant. The flow of fluids through piping systems is controlled by valves. In order to keep fluids flowing smoothly, operators need to know how valves operate and how to keep them working properly. Valves are used to control the flow of liquids or gases in a plant. When a valve is opened, flow begins. When a valve is closed, flow is stopped. Many valves operate in either the fully open or fully closed position. These kinds of valves may be referred to as on-off valves. Other valves regulate or throttle fluid flow. This can be done by partially opening or closing a valve. Valves that operate in this way are called throttling valves. Some valves may allow fluid flow in only one direction. These valves are called one-way valves or check valves. Still other valves are used to relieve excess pressure from a process system to protect equipment and personnel. These valves are called relief valves or safety valves. Regardless of the types of valves in a process system, all of them must be correctly positioned for the system to operate properly. Positioning valves so that the ones that should be open are open and the ones that should be closed are closed is called lining up the valves. Your plant procedures probably contain routine valve lineups. They may also include checklists to show what the proper positions of the valve should be for particular process operations, as well as piping system diagrams, which can be used to help determine valve locations and positions. When performing a valve lineup, an operator would use checklists and piping system diagrams to verify valve identifications and positions. Valves are usually labeled with ID numbers that are also shown on checklists and diagrams. By cross-checking the number on the valve label with the number on the checklist and the piping system diagram, an operator can make sure that he's at the right valve. The operator can then position that valve as specified in the checklist. These steps should be repeated for all the valves on the checklist until the valve lineup is complete. Even though valves may look different, many types of valves have the same basic parts. Being able to operate valves properly and identify problems that may occur requires an understanding of valve construction. The main part of most valves is the valve body. This is the part of the valve through which the fluid passes. The valve body also contains some of the other valve parts and provides the means to connect the valve to other components. The method used to connect a valve in a piping system depends on system characteristics such as the amount of pressure that the connection must contain. There are essentially three main methods of attaching valves in piping systems. The connection may be welded, threaded, or flanged. Welded connections are used in steam lines or high-pressure process piping where other means of attachment may be more likely to leak. Threaded connections are generally used on small valves in low-pressure systems. And flanged connections are commonly used where operating conditions may require frequent valve replacement or repair. Other parts of a valve may include a seating area or seat, a disc, a bonnet, packing material, a packing gland, and a stem with a hand wheel attached to it. The seating area or seat is a stationary part of a valve. It's used with the disc, which is a movable part, to control flow through the valve. As the disc moves toward the seat, flow through the valve is reduced. And when the disc presses against the seat, flow through the valve is stopped. As the disc moves away from the seat, flow through the valve is increased until the disc reaches its limit of travel. At this point, the valve is fully open and maximum flow is passing through the valve. When a valve is partially open, the valve is said to be in a throttled position. The disc is attached to the stem, which in turn is attached to the hand wheel. As the hand wheel is turned, the stem moves. This repositions the disc with regard to the seat and changes the flow through the valve. The valve bonnet seals the top of the valve body. The stem extends through the bonnet and into a space called a stuffing box. The stuffing box holds the packing, which is installed around the stem. The packing is flexible and leak resistant. It prevents leakage from the valve along the stem. The pressure applied to the packing by the packing gland is adjusted using gland nuts. The pressure is adjusted so that the valve stem can be moved as the valve is repositioned, but leakage does not occur around the stem. Valves, like many other components, require some routine maintenance and are susceptible to mechanical problems. In this part of the program, we're going to take a look at one type of valve problem, a leak. Then we'll look at a routine maintenance task that an operator may have to perform to keep valves operating properly. If a valve's packing becomes worn or fails completely, fluid will leak out around the stem. This type of leak is commonly referred to as a packing leak. In most valves, the packing can be adjusted to stop minor packing leaks. Packing is adjusted by alternately tightening the packing gland nuts, usually a quarter turn each at a time. This ensures that the packing gland doesn't become cocked in the stuffing box as the gland nuts are tightened. The packing is not the only place where a valve may leak. Another place is the joint where the bonnet of the valve attaches to the body. A leak in this area is commonly referred to as a body-to-bonnet leak. Still another place that valves can leak is where the body of the valve attaches to the piping system. On valve bodies with flanges, this leak is commonly called a flange leak. On valves that are attached to piping using methods other than flanged connections, this leak may simply be called a connection leak. The final leak that we're going to look at, and one that is not so obvious, is an internal leak through a valve. As a valve disc and seat wear, fluid may begin to leak by the seat when the valve is fully closed. When this happens, the valve is said to be leaking through. This leak can be detected only by carefully observing plant instrumentation or conditions on both sides of the valve. Besides locating and identifying leaks, another task that an operator may have to perform is valve lubrication. Valves need lubrication to prevent components from wearing during operation. Each type of valve may require a different type of lubricant or method to apply the lubricant. For example, some valves have grease fittings and require the use of a grease gun to lubricate them, while other valves may have the lubricant applied directly to a component, such as this valve stem. Because there's so many different methods that may be used to apply lubricant, you should always check your company's procedures before lubricating a valve. In this topic, we've seen how valves are used to control the flow of fluids, and we've identified some basic valve components. We also saw some methods used to attach valves to process piping, as well as some maintenance tasks an operator may have to perform.